हाँ जी, यस, स्क्रीन शेयर हो रही है आप लोगों के साथ?
बिल्कुल सही, स्क्रीन शेयर हो रही है।
ठीक हो गया। अच्छा, the last discussion what we made in our topic, that was basically the gravitation force, and we have studied about the gravitation force. Right now we will talk about gravitation field strength and gravitational potential, inshallah, together. Okay, so gravitational field strength and gravitational potential. First I will talk about gravitational field strength, and then I will reach to the next topic. Okay, gravitational field is actually that force per unit mass. Actually, we have to change the statement, as I told you in the beginning of this lecture. Okay, gravitational field was not supposed to that area in which the gravitation force acts upon, but that is the force per unit mass. We have to define in this way. Okay, that is why gravitational field strength and gravitational force, gravitational field are considered as the same. तो आपके पास ये होगा कि gravitational strength at any point is the force per unit mass at that point. So we will consider this definition in your exam. So according to that, what will we do? We just use the equation for definition from the definition. So equation is that G is equals to F divided by M, where F is the force and M is the mass. So when you replace its units, force has unit Newton and mass has unit kg. So its gravitational field strength unit is Newton per kg. What is its unit? Newton per kg. So gravitational field strength on the surface of the earth is basically 9.81 meter per second, 9.81 meter per second, or 9.81 Newton per kg. So these are same games, no issues at all. Then we have to derive it and recall it. So as I have told you, that when we will recall that, it is G is equals to Gm divided by R square. It is just for your memory recall. You have to recall this equation, but its derivation is quite simple. That by definition, G is equals to F by M. And yes, walaikum salam. How are you? Do you hear me, Abdullah?
वो सर ही लेफ्ट।
He left. Okay. आपको मेरी आवाज सही आ रही है ना?
बिल्कुल सही
जब
है।
कोई मसला परेशानी हो मुझे बताना, बिकॉज आज
सही है।
थोड़ा सा इस्लामाबाद में इंटरनेट का इशू है. सो
अच्छा, वो
मे बी
प्रोटेस्ट हो रही है इसकी वजह से।
यस, फॉर प्रोटेस्ट उन्होंने काफी सारा नेट के ऊपर प्रॉब्लम किए हुए हैं, बट अभी तक चल रहा है अल्हम्दुलिल्लाह. लेकिन हो सकता है बीच में कोई प्रॉब्लम हो जाए. ओके, सो
सही।
दिस इज जी एम एम डिवाइडेड
Hello,
बाय आर
sir.
स्क्वायर इन
Sorry.
10. यस, डू यू हियर मी अब्दुल्ला? हेलो अब्दुल्ला मखदूम, आर यू देयर? आर यू just left off? Abdullah Makhdoom. Okay, Abdullah, you can text me on the mobile if you have any problem, right? Mobile पे text कर दो if you hear me. Okay, so right from here we will just consider कि f की value क्या है. F is gmm divided by r square. So that m, this m is placed here as it is. So it would be cut. So after cancellation, mass and mass will be gone, and you will get gm divided
सर
by r. So here
हाउ डू वी नो कि स्मॉल मैथ्स है, मतलब बड़ा वाला एम क्यों नहीं हो सकता?
small mass is basically by law of gravitation. We came to now, okay, if this is a capital mass, capital M, and this is small m, then the force between these two masses will be G M M divided by R square. Okay, this is gravitational force, right?
सही।
And if this force is acting upon this mass, then I will just put small m here, and that is why it would be cancelled out.
ओके, अगर अपोजिट होता तो बड़ा वाला एम क्यों है वो?
हाँ, अपोजिट होता तो बड़े वाला, लेकिन बड़े वाला कटता नहीं है, बिकॉज द बिगर मास इज द सोर्स ऑफ ग्रेविटेशनल फील्ड स्ट्रेंथ. सो इट इज नॉट एक्चुअली पर यूनिट मास. यूनिट मास के लिए हम लोग क्या करेंगे? फॉर यूनिट मास वी विल यूज दिस स्मॉल m.
सही है।
Okay, okay, then we
Hello,
have the
sir.
variation in G. Yes, Abdullah.
Sir, I kept on disconnecting, sir. So I went to different area.
Oh, where are you? मुझे लग रहा है पाकिस्तान आ गए हो.
नहीं सर, वैसे कोई मसला था, पता नहीं क्यों.
इंटरनेट का इशू होगा, बिकॉज इंटरनेट का इशू वैसे हमारे यहाँ ज्यादा है, लेकिन आई होप दैट इट वुड बी नाउ रिजॉल्व.
सही।
Yes, sir, it's resolved.
Okay. Okay, so should we continue?
Yes, sir, continue.
Okay, so I was saying that there is a variation in the G. So variation in the G was, one of them was above and one was the below. So above the surface, it is basically, we have gone through this topic, if you people remember. Above the surface of the G or above the surface of the earth, value of G will be inversely proportional to distance, or the distance moved from the surface. That's why we will have this formula, that G is inversely proportional to square of R. G is inversely proportional to square of R. Okay, so why? Because it is coming from formula, coming from equation. From equation we came to know that the gravitational field strength is inversely proportional to R square. तो अगर आप ये देखेंगे कि if the distance is increased by 2, the gravitational field strength will be reduced by 4 as a factor of 4, right? So it would be just a simple assumption that you will use that formula, gmm divided by r square. So by using this formula, we will be able to calculate at what distance gravitational field strength क्या होगी आपके पास. So that's fine. With altitude हम लोगों ने कर लिया था. Then I told you that if you want to calculate the gravitational field strength at different positions, for example, once you are going to calculate the gravitational field strength at point R, and the second you are going to find at R plus H, at a little above from the surface of the earth, then what will you do? You will use this ratio method, and that ratio method is basically G at height, gravitational field strength at height divided by gravitational field strength at the surface, is equals to radius, I mean the value of the
Different.
radius of the planet
अच्छा,
divided by radius plus h, because that is inversely proportional ना. तो आप simply यहाँ पे यूं समझ लीजिए, this equation will help you out, that g1 divided by g2 is equals to r2 divided by r1. R2 will be bigger, I mean the distance above the surface of the earth. For example, this is earth, so this is your R1, and here you will find G1. But if you want to calculate G2 over here at a distance above, so this is your R2, okay? And here gravitational field strength is G2. So G2 divided by G1 is equals to, yeah, G1 divided by G2 is equal to R2 divided by R1. So that is inversely proportional.
G2
Problem?
जो होगा हमेशा G1 से कम होगा.
Yes, G2 will be always less than G1.
ठीक है.
Okay? Now there was a discussion made for below the surface of the earth, and I told you that when we will talking about the gravitational field strength below the surface of the earth, there will be a situation that, let's say if you are making a tunnel in the earth, check this one out, and this tunnel leads you to the center of the earth, check this one out, and when you will go to the center of the earth here, what will happen? You will be oscillated back. I mean, you will cross it and you will move away from the center. Similarly, when you will move away from the center, gravity will pull you back and you will come to the center, and due to inertia, you will cross it. So in this way, it is just, this tunnel is just an oscillating tunnel. You will be oscillating throughout that. So simply speaking, this concept will refer you, if I have this uh, uh, I mean this circle, the outer circle, this is basically the complete earth till outer boundary. This is the outer boundary of the earth. So its radius is r, and I can say that its value of g for here, it will be g m divided by r square. But when I will reach to this area, this inner ground, this one, where the distance is now smaller, actually you have gone depth, I mean deep into. So when you have gone deep into, आप यहाँ पे पहुंचे हो, you have covered d distance inside the earth. So remaining earth is this one, only this one, this inner dotted circle. That is your earth right now. So when you are moving or when you are reaching to this point, basically now the remaining distance or remaining earth is very small. So the volume is decreased. So new volume of the earth is basically 4 by 3 pi and remaining this r ka cube. Okay? So just plug in this all in the formula that F is equals to G is equals to F by M. Here, there is interesting thing, that is the force is Gmm divided by r minus d whole square. R minus d is basically your small r, which is the inner inside the earth. And when you will cancel these all, mass will be cancelled by mass, right? The remaining value is Gm divided by r minus d whole square. ये आपके पास basically क्या आ गया? This is the value of small g, right? I will now replace this m because mass is reduced. So when mass is reduced, you can simply say that mass is equals to density into volume. Okay? Mass is equal to density times volume. So your mass of the new region of the earth is density into 4 by 3 pi into remaining radius ka cube. So you will just place the value of mass here in this equation and you will get that it will be gm g into 4 pi into density divided by 3 and r minus d divided by r minus d. One is having cube, one is having square, so it would be cut by 1 और आपके पास क्या बच जाएगा? g is equals to 4 by 3 pi g into rho into r minus d, where r minus d is your small r. So that tells you that your value of g is directly proportional to the distance you have reached to the, below the surface of the earth. तो मैंने उस दिन ये बताया था कि as you are moving into d is increasing, when d is increasing actually your g is decreasing when you are getting closer. So this is what, that g is directly proportional to small r, yani this is small r value. Okay? So due to that, these all calculations will not be asked to you for derivation. That simple thing what I wanted from here, I wanted to get this graph, that red portion, that g is directly proportional to r, small r, below the surface of ऊपर उसे, ऊपर उसे. Okay, so you have to consider this graph.
अच्छा ये
right?
मैक पॉइंट होगा, ये जी की वैल्यू होगी 9.81.
9.81. 9.81 will be here. This is the highest point. For Earth, it is 9.81. For different planet, it would be different. But
सही है.
for Earth, it will be 9.81. Right? Clear है ये? Then, what calculations you are supposed to make from here? You are supposed to make the calculations of density of the Earth, mass of the Earth, radius of the Earth. Even I will say that you can calculate, even give the capital G, gravitational constant, universal gravitational constant. So just use this equation that g is equal to 4 by 3 pi r g into r, and from this one, if you want to rearrange the stuff, that g is equals to f divided by m. So f is basically this all, and you will get the value. So from here, if you want to make small g as a subject, it would be this one. If you want to make mass as a subject, you can do that from here. If you want to make r as a subject, you can derive it. I am not going to derive every step for the derivation for the calculation, but simply you can derive every calculation. You can derive every expression for this all. So I'm just going to give you a type of idea from the worksheet कि what type of questions are there, derivations बताता हूँ, and फिर हम लोग इस topic के बाद दूसरे topic पे जाते हैं. And just give me a second.
derivation included है.
The derivation of different parameters is included. For example, you can calculate mass, you can calculate gravitational field strength, and etc etc.
अच्छा.
आपका जरूरी नहीं है स्मॉल जी की डेरिवेशन करवाए वो. डेरिवेशन कैन बी डन फ्रॉम डिफरेंट एरियाज. वही मैं आप लोगों को दिखा रहा हूँ कि व्हेन यू आर हैविंग the derivation in the syllabus. So what type of derivation we will have? Okay,
Sorry.
just a second. This is planetary motion question, and ये देखो, no, this is Kepler's law. Sorry, this is Kepler's law. We can have planetary motion in Kepler's law, phi, and then gravitational law. Gravitation potential and potential energy, and gravitational fields, Newton's laws. There would be some sort of derivation which will be coming via gravitational field strength. Yes, check this one out. This is a sort of question. For example, here, this is the gravitational field strength question. Define gravitational field strength. So what will you
Sir,
what
force
will you
per
write?
unit mass.
Yes, so you will write force per unit mass at that point. Force per unit mass at that point. Right. So right after that, it is said that an isolated star has a radius capital R. The mass of the star may be considered to be the point mass at the center of the star. The gravitational field strength at the surface is GS. GS is basically gravitational field strength at the surface. On 1.1, sketch the graph to show the the variation with gravitational field strength of the
Sir,
star with distance Gs.
sir, it will be like a exponential, like decreasing the curve.
Decreasing, yes. So you
Yeah,
should
from
consider
1
the
to 2
distance
hours, very big T.
in range R to 4R. So at R, this is not the center, this is R. So at R, this is this point because that is
Maximum.
GS. He told us it is GS. At 2R, it will be how much? It will be
1 year before.
when if R is multiplied by 2, G will be divided by 4. So
Oh,
divided by 4 कितना हो जाएगा? 0.25. Okay,
yes.
it would be 0.25. So 0.25 will be anywhere 0.2, 0.25, probably here at this point, right? And when it would be 3R at
0.0625.
0.06, because when R will be multiplied by 3, G will be divided by 9. So 1 by 9 is 0.11. Okay, so it would be
0.1, yeah.
anywhere 0.11. So it would be
Uh,
anywhere closer to this point. And if you say that it is at 4R, when G will be, sorry, when R will be multiplied by 4, your G will be divided by 16. Is it
16.
clear? So 1 by
Yeah.
16, just do 1 by 16, please.
0.0625.
Yeah, 0.0625. So it is 0.06, it will be very closer to axis. Although it will not touch the axis, but it will be closer to axis. So just shuffling these points a little bit above. ठीक है जी.
ये
So
जब तक
it
फील्ड
is
में होगा
less,
उस वक्त तक जीरो हिट नहीं करेगा उसकी.
नहीं हिट करेगा.
ओके,
ठीक
जैसे
है.
ही फील्ड से बाहर
So
निकलेगा तो जीरो हो जाएगा.
yes, when it will reach to the infinity, ना infinity पे
अच्छा.
आपके पास ये zero को touch करेगा. Because
ओके.
at infinity it would be 0. So you will just join these points something like this. So this is the graph what I have told you कि आपका graph ऐसा होता है because graph is asked to you. ठीक है? Is it clear to all of
सही.
both of you?
यस.
Okay.
Yes, sir.
So you will draw this like this.
सर बेस्ट है
जरूरी
तो
नहीं है
ये.
मीन हाँ जरूरी नहीं है सारे पॉइंट्स ज्वाइन कर दो but it shows the trend. You people can
ओके.
show the trend. Okay. The next is the Earth and the Moon may be considered to the spheres that are isolated in the space with their mass concentrated at their centers. the mass of the earth and the moon is 6.0 into 10 raised power 24 and 7.40 into 10 raised power 22. This is mass of the earth, so let's call it m1. This is mass of the moon, so let's call it m2. The radius of the earth e is, and the separation between the center of the earth and moon is 60 re. Okay, this is also given to you in terms of re's, right, as illustrated in the figure. Explain why there is a point between the earth and the moon at which the gravitational field strength is zero. Yes, this is the question related to the topic of forces, that why gravitation field strength is zero. So as I told you, that what is gravitation field strength? It is basically force per unit mass. Okay, so for example, we are here, I am the mass, and we are moving at a point, like at this point, if the force of attraction due to earth, this is force of E, and it is actually mass m which is traveling through, and this is the force of moon. If both are equal in magnitude, then gravitational field strength will be zero. So you will say that there is a point where there is a point where force of earth or gravitational force of earth is equal and opposite to the gravitational force of moon. So at that point both forces cancel the effect of each other.
Net force 0.
Yes, forces are cancelled and net force goes to zero, F net goes to zero. So gravitation field strength is equals to zero, because gravitation field strength is force per unit mass. That's it. Okay.
आजकल इसके अंदर रेफरेंस नहीं रहते उसका काइनेटिक एनर्जी और पोटेंशियल एनर्जी का.
नहीं, इसमें जरूरत नहीं है, बिकॉज काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी इज नॉट कंसीडर्ड हियर.
अच्छा
ठीक है, उसने बोला है कि आपने ग्रेविटेशन फील्ड स्ट्रेंथ, व्हाई ग्रेविटेशन फील्ड स्ट्रेंथ इज जीरो, दैट्स व्हाई. ओके, then
सही है.
determine the distance in terms of re from the center of the earth at which the gravitational field strength is zero. So interesting question. You have to find that point where re is zero. So I'm going to find some space here. इसके लिए जगह कम है थोड़ी सी, मैं इसको यहाँ सॉल्व कर देता हूँ and then I will go back for the graph. Here both the forces are equal, so force 1 is equals to force 2. So force of earth is G, mass of earth, into small m divided by r square, oh sorry, d square. If you remember, I just told you that formula. It is d square, and that is equals to G, mass of moon, into small m divided by r minus d square. Is it clear to you?
Yes.
Actually ये d कहाँ से आया, r कहाँ से आया? Just assume कि this is the distance from the center of the earth. This is distance d at which the forces are balanced. So this is d. The distance between center of the earth and center of the moon is r. इसको just हम लोगों ने consider किया हुआ कि that distance is r. So what will be this remaining distance?
D minus R minus G.
That will be r minus d. Okay, that will be r minus d. So for this object, which is basically your mass, if it is here, gravitational field strength of earth is calculated at this much separation, and gravitation force of earth and then gravitation force of moon is calculated at this much separation. So when we reach to this point, check करो, मैंने दोनों के लिए अलग अलग काम कर दिया. Then G will be cancelled by G, small m will be cancelled by small m, and you will have this formula, that mass of earth divided by mass of moon. We can just make it or just in one step हम लोग कर लेंगे. Then mass of moon divided by r minus d whole square. because we have to find the distance, right? So I will make this d as a subject, but for that purpose I will have to make the ratio of mass of earth divided by mass of moon is equals to d divided by r minus d whole square. If you remember the previous lecture, इससे पहले वाला, I just derived this formula for you people, that this formula is used for calculation, right?
Hmm.
यही एग्जैक्ट यही फॉर्मूला डिराइव करवाया था मैंने. सो मैस ऑफ द अर्थ इज 6.00 into 10 raised power 24. Mass of the moon is 7.40 into 10 raised power 22, and d is unknown, and the separation between these are, अभी मैं इसको r minus d ही लिख रहा हूँ just for a reason. Just I will take square root and I will just make this separate. जस्ट प्लीज कैलकुलेट कर दीजिए मुझे ये दिस लेफ्ट हैंड साइड.
81.08.
81.08 is equals to d divided by, it is your 60 re, if you remember.
Yes, sir.
Okay, yes, just after that I will make it. Just a second. It is r minus d, r minus d. So I'm just taking whole square on, I mean square root on both sides. So it would become
9.
9.0 is equals to d divided by r minus d. So from here, my d will be
Sir,
equals
90.
to
Oh, 90
90 तो
or
नहीं होगा,
minus.
81.
Sir, 9 or 9.
9r minus, so d would
90.
be, what will be d? Just calculate this. 9r, okay, कर लेते हैं.
10D is equal to 9R.
Yes, 10d equals 9r. So 9r is equals 9r is equals to 10d. 10d. So d will be basically equals to 0.9 times r. Sorry, r. Small r. Okay, is it clear till this point? So your d is 0.9 times, what is this r? R is 60 times re, radius of the earth. So just multiply kariye. So I
54.
think it will be 54 re,
54.
right?
54 RE.
Yes. So the distance is 54 re. Is it clear to all of you?
अच्छा सर, ये जो हमने F1 F equals F2 और जो हमने स्मॉल मैथ्स कट किए थे, ये जो स्मॉल मैथ्स हमने सपोज किया था या क्वेश्चन में मेंशन था कि एक
नहीं
स्मॉल
नहीं,
मैथ्स जा रहा है?
there is a, actually it is supposed ke there is a point, so definitely that point would have some mass na. Earth and the moon is considered to be the radius of the masses of the earth and the moon are given to you. The radius is this is explain why there is a point between. So there is a point, so if some person or a rock or any object is existing there, its mass will be small m, which is experiencing both forces.
सही है, ठीक है.
ये क्लियर है सबको?
यस.
So check कर लो कि this is what, this all is your derivation. You have to calculation. Now you will get 4 marks or 3 marks here. Okay, is it clear to you?
यस.
54e. So you can just use that calculation for 3 marks. There will be a space given, don't worry about that. इतनी space कम नहीं होगी. So that is 54 re. देखो, that answer is in form of re. It is not in terms of units. Sometimes we are having data. Yeah, radius of the earth is this. We can calculate because I can tell you the radius of the earth. So what is radius of the earth? Radius of the earth is basically 6.4 into 10 raised power 6 meter. So if you plug in the value here, you can get the numerical value in meters or kilometers. ठीक है?
सर कहाँ
Clear है
डालेंगे
सब?
रेडियस?
आर ई की जगह यहाँ पे,
अच्छा उसने
because
आर ई
that
कहा
is,
है कि वो
हाँ,
रेडियस है।
yeah, that is actually in the form of RE. This is not in meters or kilometers.
सही है, ओके।
ठीक हो गया। अच्छा, फिर एक और मजे की बात, sometimes the same question is asked to you that calculate from the surface of the earth. Calculate from surface of the earth. So for surface of the earth, what will you do? 54 minus 1 कर दोगे,
-1।
because surface देखो कहाँ पे है, your surface of the earth is here, that is r from the center. So if this distance is 54 RE, then what about this
अच्छा,
distance? 53
ओके,
RE. ठीक है ना?
सही है, सही।
So just consider, I'm just giving you the ideas about the questions. Questions can be from different domains, but they would be having the same pattern. Okay? अब वो कह रहा है कि on the axis of figure 1.3, sketch the graph to show the variation of gravitational field strength with position where the surface of the earth and surface of the moon. So surface of the earth is here, okay, and then surface of the moon is here. मैं just यहाँ पे इसको शो करता हूँ थोड़ा थिक करके पेन, सो दैट इट वुड बी विजिबल. Okay, at the surface of the earth the gravitational field strength is maximum, right? You have to draw from surface, so because you are not supposed to draw from center to surface, ये आपने नहीं करना because it is not asked. What is asked? From surface. So from surface there will be a point where it will be go to zero. Let's say that is that point.
अरे सर आपने तो कहा था कि जीरो तो इन्फिनिटी में होगा।
नहीं नहीं, ये देखो ये दो पॉइंट्स के बीच में है ना, हमने यही तो यहाँ पे फॉर्मूला क्यों लगाया कि देयर विल बी अ
हाँ,
पॉइंट वेयर ग्रेविटेशनल फील्ड स्ट्रेंथ इज इक्वल टू जीरो,
सही
बिकॉज
सही।
दो पॉइंट्स के बीच में टू फोर्सेस आर एक्टिंग इन अपोजिट डायरेक्शन, दैट्स व्हाई इट वुड बी जीरो. ठीक है,
ओके, सही।
तो
अगर मून
आपके
नहीं हो तो
पास,
फिर इन्फिनिटी में जीरो होता।
हाँ, फिर आपका ग्राफ एक्सिस को टच नहीं करेगा एंड देन इट वुड बी कमिंग डाउन. ये सरफेस है ना मून की, तो मून की सरफेस पे ग्रेविटेशन फील्ड स्ट्रेंथ विल बी लेस, so your graph will be something like this. Okay, is it clear to all of you? Yes. So these type of questions are there which are basically coming from that derivation or derivations or calculations what I have told you. ठीक है?
ठीक है।
Yes, there is another question like this. Check this one out. But it has some gravitational potential energy consideration later on. That's why we will discuss that when we will be done with gravitational potential energy. ठीक है जी? This is variation of gravitational field strength. Check this one out. This question is the same, coming from the same topic, that the definition of electric potential and gravitational potential at a point have the some similarities and differences are there when we will be done with electric field. तो उसमें आपका हो जाएगा explain why the value of the gravitational potentials are always negative where the gravitation value of electrical, okay, sorry, this is from electrical potential, just leave it. Okay, so I believe that in this worksheet there were few questions, एक उनमें से मैंने ढूंढ लिया and rest if we will find हम लोग कर लेंगे. Right, any question till this point?
नो सर, सही है।
Okay, अब हम लोग आते हैं ग्रेविटेशन पोटेंशियल पे.
सर ये वैसे ही चैप्टर लाइक कब तक फिनिश होगा, ये पूछ रहा हूँ।
जब खत्म करूं